Okay, so this video, even though it's the homework page in your packet, it's actually also a really good test review since it goes through all these properties. And I'm even going to add in other parts. Let's add in range. I'm going to do that. And I'm also going to add in end behavior. That way you have everything to practice from these equations for the test. What I also have here on the screen, this is an image of my summary sheet. If you are not currently keeping a summary sheet or index cards or flashcards or something summarizing all this information, it's just too much. You have to have a summary sheet to help you practice finding all the properties. Okay, for number one, I'm going to first factor my numerator and denominator. So what multiplies to -2 that adds to 1 is +2, -1. What multiplies to -6 that adds to -1 is -3 and +2. Okay, part A. Woo. Domain. I come to my summary sheet. It's all real numbers, but x cannot be the vertical asymptote values. Vertical asymptote, that's when the denominator can't be 0. So here's my denominator. It's already factored. When these values can't equal 0 is going to be my domain. So when each factor can't equal 0, solve. So that's x can't equal 3, x can't equal -2. Part B is the wholes. So my notes to myself here. If a factor cancels, there is a whole. I see that x plus 2 is going to divide by itself. So the whole occurs when that canceled factor equals 0. So that's at the -2. So the x coordinate is -2. Condense the equation. So my condensed equation is without the canceled factor. So I'm left with x minus 1 over x minus 3. Condense the equation, plug in x. So -2, I'm going to plug that in. I do not know why I cannot write 3 with this tablet. There we go. -3 divided by -5 is +3/5. There's the equation of our whole. So that means this x can't be -2. That got us a whole. So when I go for my vertical asymptotes, that's the equation of the line x equals 3. That's the other part missing from the domain. You can see even from the condensed equation, that's when the denominator would equal 0. All right, what's next? Vertical asymptotes, horizontal asymptotes. Horizontal asymptote, I'm going to look at the original function and compare the degrees. So the denominator degree and the numerator degree, they're equal. So that means I divide the leading coefficients. So in the front there, they're both 1s. So that horizontal asymptote is y equals 1, which means there's no slant asymptotes. Oblique and slant, they're the same. Okay, let's go for y-intercept, x-intercept, and I'm going to use the condensed equation for my x and y intercept. So let me copy this down here. Oh, whoops. There we go. X-intercept. So this is my function. For the x-intercept, I forget which part of the problem that's asking for the homework, but it says set the equation equal to 0 and solve. All right, so 0 is over 1. I'm going to cross multiply. 0 times this denominator is 0. 1 times the numerator is just x minus 1. Solve that. I get 1 for x, so that is the point 1 comma 0. The y-intercept, plug in 0 for all the x's. That gets me 1/3. So that is the point 0 comma 1/3. All right, so then at the top, I said I was adding in range and end behavior. Okay, so the range are your the y values. What can your y values be? Or not be? So the range, that's all real numbers, but y cannot be your horizontal asymptote, and y cannot be the y value of your hole. So it's similar to domain, where domain leaves out your vertical asymptote and the x value of the hole. Range, we're going to not equal the horizontal asymptote and the y value of the hole. All right, the last is end behavior. For right end behavior, oops, and I don't have this on my summary sheet that I have here, so you can add it to yours. Right end behavior always starts x goes to infinity, y goes 2, and you fill in a y value. Left end behavior always starts x goes to negative infinity, y goes 2. For rational functions, for these fraction functions, your end behavior will always be the value of your horizontal asymptote. All right, so since we found all these properties, I thought it would be nice to look at the graph and what did we actually find? So here's that vertical asymptote that we're approaching at x equals, x equals 3. Here's the horizontal asymptote at 1, and you can see the end behaviors as x goes to infinity. That y value is approaching 1. Let's go negative infinity. That y value is approaching 1. Our x-intercept, 1, 0. Our y-intercept, there's that 1/3. And the hole, where was the hole? At negative 2. Let's see if it lets me click. Nope. So you can see at negative 2, it says undefined because there is no y value on this graph. At negative 2, we found it. It's the hole. All right, number 1 done. Number 2, same properties. I'm going to also add in the end behavior and the range. Factor, let's factor the numerator. Well, nothing factors in the numerator. Let's factor the denominator. This is the difference of two perfect squares. So it factors to conjugates, opposite signs in the middle there. Domain. Where's part A? I should have just written part A. Is when the denominator can't equal 0. So each factor cannot equal 0. So x cannot equal -1. X cannot equal +1. Because when you solve this, whoops, we get the -1 and +1. For wholes, there isn't any. There are no wholes because there's no factors that divide. For vertical asymptotes, it's both values that made the denominator 0. So x equals -1, x equals 1. These are equations of lines. You have to write x equals x equals. For horizontal asymptotes, I look at my degrees, look at my exponents. They're equal again. So I divide the leading coefficients. It's y equals 2. So that means there's no slant asymptote, no oblique asymptote. All right, let's go for x and y intercept. Y intercept is when x is 0. So 0 squared is 0 times 2 is still 0. 0 divided by anything is 0. So our y-intercept is 0, 0. X-intercept, it's going to be the same thing. When I set my whole equation equal to 0, make 0 into a fraction, cross multiply. So 0 times the denominator, 0. 1 times the numerator. Isolate the x. And the square root of 0 is 0. So the x-intercept is the x-coordinate 0 and the y-coordinate 0. All right, let's do range. All real numbers, but y cannot equal 2. Okay, go right end behavior. X goes to infinity. Y goes to something. It's always the horizontal asymptote. Left end behavior. X goes to -infinity. Y goes to horizontal asymptote. All right, number 3. Domain. When the denominator can't equal 0, x cannot be 2. There's nothing to factor. That's nice for this one. B, no holes, nothing simplifies from there. Nothing factors, nothing cancels. C, the vertical asymptote is the line, x equals 2. D, the horizontal asymptote, y equals, let's see. Oh, wait, this is a different form of the equation. This is transformation form. There we go. Where we have our constant, this 3 over the x minus h, and there is no plus k. So it's like a plus 0. So that's a horizontal asymptote of y equals 0. Another way you can think of it is there is no x in the numerator, so the denominator degree is larger because the degree is 1, and there is no degree in the numerator. No slant asymptote. Y-intercept is when x is 0. That's -3 over 2. So the point 0, negative, oh my gosh, -3 over 2. X-intercept is when your whole equation equals 0. 0 times the denominator, 0. 1 times 3, 3. Wait, that doesn't make sense. 0 equals 3? No. So there's no x-intercept, which makes sense if the horizontal asymptote is the x-axis. Okay, let's do range. All reals y cannot be 0. Right end behavior. X goes to infinity. Y goes to 0. Left end behavior. X goes to negative infinity. So y goes to still 0. And since this is transformation form, let's talk about the transformations too. What transformations happen here? So the -2 on the bottom is a right 2, and the 3 in the numerator is a vertical dilation or a stretch of 3. Some good test review practice there. Okay, number 4. Number 4, back to not transformation form. See how we have an x in the numerator? That's not the transformation form. So back to what we were doing before. Nothing factors, yippity doo-dah. So let's do domain. Hey, the denominator is just x. X can't be 0. B, no holes. C, vertical asymptote, x equals 0. Oh, wait, I forgot something. I wanted to show you what this graph looked like. Sorry. No x-intercept. See how we have no x-intercept? Because the horizontal asymptote is the x-axis. Let's zoom out. Where's that vertical asymptote? Right here. Here's that vertical asymptote. Where did we say that was? At 2. Right here at 2. End behavior, as we go to infinity, that graph is approaching 0. Let's look left end behavior, also approaching 0. Where's the center? Domain, all x values except this vertical asymptote. Range, all y values except 0 here. Oh, and here's that y-intercept. Okay. Now let's continue on. Sorry about that. 4. Where were we? Vertical asymptotes. Horizontal asymptote. Degrees are the same. Divide the coefficients. That's 2 over 1. No slant asymptotes. All right. Y-intercept. When x is 0. Uh-oh. Can't have 0 in the denominator. There's no y-intercept. X-intercept. Set your function equal to 0. Cross multiply. Isolate the x. We get 1/2 is x, so that's the point 1/2 comma 0. So the range, just for some good test review practice, all reals y can't be 2. We exclude the vertical asymptote. As the horizontal, we exclude the horizontal asymptote. End behavior, right end behavior. X goes to infinity. Y approaches horizontal asymptote. Left end behavior. X goes to negative infinity. Y approaches horizontal asymptote. We're going to get no slant asymptotes on this homework? What is happening here? Okay. Here we go again. Factoring. Yes. What multiplies to negative 12 that adds to 1 is going to be positive 4, negative 3. Negative 3. X squared minus 9 is the difference of perfect squares. So it factors to conjugates. Oh, look at that. We have a whole. All right, we'll get there in a second. Domain. All reals. X cannot be. What makes your denominator 0? Negative 3. X cannot be positive 3. B. Yes, we have a whole. This is the factor that cancels. When is x minus 3 0? That's at 3. To find the y coordinate, let's see, I don't remember. I come to my summary sheet, condense the equation, plug in x to find the y coordinate. Please make a summary sheet. Please, please. It will make this unit and studying for your tests so much easier. All right, we take 3 and plug it in. 3 plus 4, 3 plus 3, 7 over 6. So my vertical asymptote comes from the factor that remains, or this other part of the domain, when the denominator equals 0. That's our x equals negative 3. Horizontal asymptote. I'm going to come back to my original. Degrees are the same. Divide our leading coefficients. No slant asymptotes. Y-intercept. The y-intercept. Everywhere x is 0. I'm going to use the condensed version because it's less numbers. It's easier to work with. It's condensed. That's 4/3. So 0, 4/3. X-intercept. Set the whole equation equal to 0. Over 1. I'm going to cross multiply. 0 times the denominator. 0. 1 times the numerator is just that numerator. So negative 4 is x. So that is the point negative 4, 0. Range. All real numbers. Y cannot be the y coordinate of the whole. And y cannot be the horizontal asymptote. Are you getting the hang of end behavior? Right end behavior. X goes to infinity. Y goes to horizontal asymptote. Left end behavior. X goes to negative infinity. Y goes to horizontal asymptote. Let's look at this one too. Why not? If you're not interested, fast forward the video. Whoa. y-intercept, x-intercept, vertical asymptote, horizontal asymptote. Where's the hole? Where did we say it? 3. Undefined at 3. Right here. All right, last one. Domain. X plus 3 cannot equal 0. So x cannot equal -3. No holes. Well, I should prove that. Okay, let's factor the numerator. X squared minus 4 is the difference of perfect squares. X plus 2 and x minus 2 are not going to cancel and simplify with x plus 3, so no holes. C, vertical asymptote, x equals -3. Horizontal asymptote, now, finally, the denominator is a smaller degree. 1 is smaller than 2, so it's a slant asymptote. It's not a horizontal one. So I actually have to find the slant and oblique asymptote. I will show the division both ways because there's an issue with this that we did not cover in class today. This numerator, x squared minus 4, can also be x, don't do this to me, pen, x squared plus 0x minus 4. When we're dividing, whether it's box method or long division, you really have to hold the spot for that missing term, that missing 0x. Otherwise, pieces won't light up when you're dividing. All right, box method. First term goes back in the box. We do x squared divided by x. Write it out if you have to. Law of exponents says subtract the exponents. We get x to the first. This box gets filled in length times width. So x, because this is x, by width 3, that's 3x. This diagonal has to add up to 0. So I like to subtract 0x minus 3x, because I subtract this way, gets me -3x. Repeat, -3x divided by x, -3. -3 times 3 is -9. However, when we're dividing for slant asymptotes, I don't care about this remainder. So the answer, the slant asymptote is y equals, because it's a line, y equals x minus 3. For long division, if you're a long divider, we've got x plus 3 divided by x squared plus 0x minus 4. Same process, different format. X squared divided by x. That's x. Multiply it back. X times x. X times 3. Then we subtract. So everything on this line is subtracted. 0, 0 minus 3x. Bring down the 4. Repeat. -3x divided by x. -3. There's your quotient. There's your slant asymptote. We will not ask you range or end behavior when there is a slant asymptote. We're just not going to do it. Okay. X-intercept, or y, let's do y-intercept. Substitute in 0. -4/3. So 0. Oh my gosh. -4/3. Kind of. X-intercept. Set the whole equation equal to 0. Make your 0 into a fraction. Cross multiply. 0 times the denominator. Whoops, that's 0. 1 times the numerator. Oh, but I already factored that. It's a difference of perfect squares. So when each factor equals 0, that's at -2, +2. So our x-intercepts are -2, 0, 2, 0. Won't ask you range or end behavior with the slant asymptote. Let's look at it because it's cool. We haven't looked at a slant asymptote yet. No. So, actually, let's graph the slant asymptote. There we go. So you can see this graph, this rational graph, the blue one, is approaching this slant asymptote, which is green. I didn't mean to zoom this out. Okay. That's it. Make sure you can do all of this for the test. I think that's all I got to say. All right, I hope this was helpful.